Okay, we'll be continuing with this session discussion. Problem C of yesterday's contest of round 3. Currently, the system test is running on, so I cannot submit the answers. But I'll just solve for the solution and later I'll submit it. Hmm. Now, what the question says that you are given an tower's number from 1 to n. Tower I has height hi. At time 0, you are on the tower with index k and current water level is 1. Every second water level rises by 1 unit. At any moment, if the water level becomes strictly greater than height of tower you're on, you perish. You have a magical ability. At moment X, you start teleporting from tower I to tower J, which will take the modulo hi minus hj seconds. That is until moment X plus hi minus hj, you will be on tower I, and at moment X plus mod hi minus hj, you will move to tower J. You can start a new teleportation at the same moment you arrived. Okay, and this is one example which is given to us. Your goal is to find if it is possible, yes or no. I'll just explain the first test case. 3, 2, 1, 4, 5. It will be better if we start visualizing things on the number line. 1, 2, 3. All the towers I'm visualizing on the number line. Let's say initially water is at this one level. And also the index is given as 3. So initially we are also at this level. Now first thing what I'll do is I'll sort the array. Because it doesn't matter if you work on unsorted array or if you work on a sorted array. After all, you get the same answer. So sorting makes our work easier. Then let's say I want to move to the tower 2. If I want if I want to move to the tower 2, how much time I need is mod of 1 minus 2, which is 1 second I'll be needing. Now on 1 second the water level will be 1 in this thing, and as soon as the water level reaches 1, I will move to the tower 2. See this tower 2 and tower 1. At first second the water level will be this thing, and as soon as water level reaches till here, I'll just teleport to here and I move to here. Now again at 2, if 2 minus 3 is there, then again 1 second I have to wait till then water level reaches again. I mean till here it reaches, then again I'll jump to the third tower, and similarly it goes on. So it's possible here for me to escape. But in what cases it's not possible to escape? Let's have a look. Let's say I'm working on the second test case where it is 1, 3, and 4. Hmm, And I'll use a blue ink. Now, let's say I'm at 1, first level right now. Now the water level is 1 in all of the. Why is it? Now water level is 1 in all of the. Blocks. Now, how much time I need to go to 1 to 3? For going from 1 to 3, I need 2 seconds. 2 seconds. But the initial height is 1. So if I just wait for 2 seconds, then I'll just drone below this water level because I need to wait 2 seconds before teleporting. Hence, it's not possible to escape over here. This 442 is, explained in the question. I'll explain this fourth test case, which might make more easier to understand. Now let's say I have 2, 3, 6, 9, 1 and 2. Now I'm at this thing, this level, third tower. I'll just work with these things. 3, 6, 9. I don't need these all remaining towers. There's no point going back to them. I'll just remove them. What I need is this thing. Now, currently, if I start drawing all the towers, let's say this is tower with height 3, and let's say this is the tower with height 6, and This is the tower with height 9. 6 and 3 more, and it's 9. Okay. Now currently I'm at tower 3 and water level is 1 in all of the blocks. Now what will I do is, if I want to go to the 6th level, I have to wait 3 seconds. Suppose I have waited for 3 seconds, then water level will come here till here, then I am good to go for escaping till here. So the water level, the differences between height hx minus hy should always be less than equal to initial water level. Then only it's possible for me to escape here. If it does not happen, then I might not be able to escape because the water level is maintaining a difference of 3 3 here. I mean, hx minus hy is initial as an initial. Suppose I got teleported to here. Now again I have to wait 3 seconds to go here. So what I'll do is I'll just wait 3 seconds, and these all water boxes will fill. As soon as 3 seconds complete, I will enter here. Suppose the initial water level is 4. Then how much seconds I need to wait? I mean, the difference should be less than 4. If the difference is less than 4, then only it will be possible for me, because the difference will be 9. I mean, 9 minus 6 is 3. Now, which is less than equal to initial height, which is 4. Means I have waited here 2 seconds, the water level will rise till 2. So after all, the thing is that if you observe, the maximum differences between these, all of them, should be less than the initial height. This is what is the observation. If you try working on all the test cases, most observation you will get is about this thing, that this should be followed, hx minus hy less than equal to initial. If I try showing on number line, I think it might become more easier. 2, 3, 4, 5, 6, 7, 8, 9, and 1 and 2. Let's just leave that. Initially I'm at tower of height 3, and water is at this thing. So I have to wait 3 seconds here. At the third second water will be here. Then I will be good to teleport here. Okay. But what if, let's say, the difference between 3 minus 6 is greater than 3? Let's say this is not 6, this is some number such as 7. Suppose if it was given as 7, then what will be the situation? I have to wait for 4 seconds here. But in 4 seconds, I'll just drone because the water level will exceed this thing. So I cannot teleport to that next level. Now let's say it's okay, we are done with this. If it was 6, we got teleported here. Now say, let's say if this difference was not less than equal to 3. Let's say suppose it was if instead of 9 it was 10. Then the difference will be 4, which is greater than 3. What will happen then? Okay, let's say I have waited 3 seconds here, water came till this thing, and I have teleported to 6. Now from 6 I have to teleport to 10. Now I have to wait 4 seconds here. But till that time, what happens is my like all the water level will overcome the 6, because I mean the water level will exceed this 6 level till I wait for 4 seconds, because the difference between 3 and 6 is 3. So it's just 3. It's possible for water to overflow here till here, and then it's not possible for me to go to 10. Suppose this was 5, the difference was 2. Yeah, it will just go on working. That's the thing, because the water level always remains 3 steps behind of me. So because the water level always remains the initial value of the our height that many steps behind of us, means it remains 3 steps behind me wherever I go. Suppose I'm at the 6th level, then water is just 3 steps behind me, and I have to wait for 3 seconds. Suppose I went till 8. At max, it will be 3 steps behind me. Suppose the difference is 2, then it might be just 2 steps behind me, but maximum difference will be 3 if you go. It's so for being as I mean for us it being possible to escape, the maximum difference will be initial height. So maximum difference, it should, I mean, the difference between all the successive ones should be less than equal to the initial height. That is what the thing, if you observe. I feel like it's a good question. I'll just add them in my playlist of revision questions. Any day I'll just move to solve them. Now we'll move to the coding part. Anyhow, I will not be able to submit this thing. This code is purely trash. I don't know what did I do. It was not required to increase the height of water always. Maybe we could do that, but I don't know why my code is not working. I think we can work with the current water level heights as well. Current water level is 1. First of all, let me just work with this thing. I'll create a set integer of s. Then what will I do is, this is the current water level, which I'll call as ci, which is a k minus 1. Now in this set, what I'll do is I'll store all the elements which are greater than a k minus 1, and I need unique elements. What I'll do is I'll just iterate. Now this will be pushed in my set. Now I'll iterate to the set. Let's just try doing with the maintaining the current water level. Let's say it's 1. Now what I'll do is it minus ci. I mean the current water will be now not 1, but it will be ak minus 1. Now what I'll do is it minus ci. If it minus ci, it minus ci is 3 minus 2, let's say it's 1. If I do current water level plus it minus ci, my current water level is it. I mean if I just begin escaping. 3 minus 1 is 2. So it minus ci is greater than current water level. And I'll just simply print a no. And I'll return the output. Else, what I'll do is, now I'll set ci to it, and the current water level will be now it minus ci. I mean current water level will increment by it minus ci, because here it's what this is what it will happen here. 369 initial current water level is 3. Now if 3 minus 6 if I do, I'll get again, I'll get as 3. Okay, so the current water level will increment by 3, and the current iterator is at it at 6. Now I'm on to iterating towards 9. And what I see is if 9 minus 6 is greater than 3, yeah, I guess it will work. If it does not work, then I have to take only the initial water levels. Yeah, it's passed. Sadly, I cannot submit here because it's not allowed. But what I saw was yesterday's test case on which it was failing. 55915. 1, 1, 4 and 2. Answer is no. Yes, I guess this will work now. This code will work. I'll just schedule it later for submission because, okay, I'll not be able to submit it. Now let's work with this question number B of the TLA eliminator sheet, which I'll be continuing. I think tomorrow I'll go with the D and E questions as well. Okay. Roof construction. It's finally decided to build a roof over football field in school 179. Its construction will require placing n consecutive vertical pillars. Furthermore, the headmaster wants the height of, okay, this is maximum value of bitwise ZOR. What I told was we need one's complement, but one's complement might be greater than n minus one or less than n minus one. That's what that is the matter of concern. This is roof construction. Now this is one's complement which I found. To make the ZOR maximum, we need one's complement. Suppose I have some number. Let's say I have 100. Then obviously 001 will make my ZOR maximum. But what if one's complement is less? Then let's say I have number 1. I don't guess one's complement will always be less than a given number. Let me just Google that. Okay, it's not always the case. And then we need to check where does it happen and where it does not. One zero zero 011. Let's say we have the current number given us. It's quite intuitive actually that one's complement is okay. We have, let's say, 101 and its one's complement is 01. Okay, we'll leave it. We have, let's say, 110, but here why am I getting always the lesser number? So we have six binary representations, 110, but if I take the one's complement, it's 1. I'll just look by outputting the values. One's complement of 1 is 0 and one's complement of 2. It's always the lesser number which I'm getting. What I'll do is I'll just output the ones complement, then n minus 1. I think I had submitted it earlier. Was it the same code or? Yeah, it was the same code. Where did it fail? Let's have a check on this. Jury's answer is better. Jury's cost 2, participant 3, and test case 2. Test case 1, test case 2. Hmm. I printed the ones complement of uh, 2, which is 1 comma 0 and 0 comma 1. 1 0 to its 2. Sorry. We have 3, then we need to work with 2. We need to find one's complement of 2, which is 1. And how can I look for the one's complement? Or else I need to go for the brute force approach. One comma two. I'll just take it as n, and I'll decrement n. Now let's try it. One's complement and n minus one. XOR of 1 and 1 is 0. XOR of 3 and 3 is 0. I'll be back in a minute. Okay. What I'll do is I'll just have decremented n by one value. Then I'll print out the ones complement. Then I'll print n. And further on, I'll go on printing the remaining numbers. Hmm. 0 1 1 2 0 3 4 0 1 2 6 9 0 1 2 3 4 5 7. Yeah, and now I'll just submit. I'll go for submission. If it doesn't work, we need to look some other ways for maximizing the XOR of number 0 to n. Test case 2. . Do I need to maximize the cost or minimize the cost? This is the maximum where when with the smallest construction cost. Okay, okay. Since this is the smallest, we printed this. Okay, I did the reverse. I need to find the one with smallest construction cost. Well, I need to look for the test case. Where is it? 102. After taking maximum of ball, I need to get what I need to get is the smallest construction cost. That's the twist in the problem. I didn't read it carefully, my bad. Hmm. Now let's say I have three, then 0, 1 and 2. Out of these numbers, I need the minimum cost out of all the maximum costs. So what I need is I don't want the maximum cost to occur. When does it occur? When the ones complement and they are together. What if I try separating them? I mean, first I'll print the ones complement, and I'll print n value. Hmm. Now let's try submitting this thing. No, I guess this will give me the wrong answer because we need the minimum cost possible as well. There's no problem in submitting, but I know this will give me a wrong answer. Okay, wrong answer on test one. Test case 3. How did the jury max minimize it? What I'll do is I'll iterate 0, 0 to n minus 1. I'll iterate. I mean, what I'll do is, let's say I have 5 years given here. Then my actual value is 4. 0, 1, 2, 3, 4. Till this n by 2, I mean till 1. What I'll do is I will print the value by which with after doing XOR I shall get minimum value. With 0, if I do XOR of 1, then I'll get 1 as minimum value. Okay, this is done. Now let's say, then I have to skip this thing. Now let's say for 2, with 2 what element do I need to find on which the XOR gives a minimum value to me? 1, 0. It's 0, then it might be 1. It might be, if I should check with 3 and 4 then. And I cannot go in n square time complexity as well. One, two, three, four. I'll do even odd. If I do 0 1, then I'll do 2 and 3. No, it will not work. 0 1, then 2. In most of the cases, 0 is centered at the center. 4 numbers here and 5 numbers here. 9 by 2. Here he kept 0 at center. Here he kept at 10 by 2 position. We just have to put a 0. What are the values at which n is ranging from 2? Okay. If I is 1 by 2, n by 2, then I'll just print a 0. 1 by 2 is 0, so at n by 2 I'll print 0 and at remaining positions, if let's say this is 5, there are 5 numbers. 5 by 2 is 3. I mean seal of 5 by 2. 1, 2, 3, no. Or I'll look for some hints. Cost of construction is a power of 2. Okay, well, and then 2 power k. Okay, where highest set bit is in n minus 1. K is the highest set bit in n minus 1. Now I need to target that cost. How do I target that cost? Okay, since it's a power of 2, since the cost of it is 2 power k, where k is highest set bit in n minus 1. And highest set bit means 4. Let's say for 5, n is equal to 5, we work on 4, and we have 1, 0, 0, 2 power 0, 2 power 1, 2 power 2. And the highest set bit is this thing, I mean 0 first and 2. The second bit is the highest set bit, and the cost will be 4. How to get the cost as 4? That's our task. Now this is the 4, and I'll be zoring with such, I'll be doing a zor with such numbers. 3, 2, 1, and there's 0. 0, 0, 0. It doesn't make sense anyhow. But I'll do zor of odd numbers there here itself. This is 4. This is 3. This is 0. This is 1, and this is 2. This is how things should happen for me. Oh no no no, we need to minimize the pairwise XOR. What if we do n XOR n of n minus 1? 3 XOR 2, let's say. 1 XOR 1 is 0 and 1 XOR 0 is 1. That is what the minimum XOR which we'll get. Or 0 1 1 0 1 1 0, this is 1. Aim is to minimize all the pairwise XORs here. think what he did here is to minimize the pairwise XORs. Till n by 2 he printed all the numbers, and after n by 2 he printed the remaining numbers. If you look closely, then let's say a is equal to 4. I mean n is 4. I mean n is 5, but after all ultimately, okay, let's say n is 5. And it took a as 1. Then maximum value till where a can go is a is equal to 2, then 2 is less than 5, then a is equal to 4, 4 is less than 5, a is equal to 8 is the maximum value till where a can go. Now a becomes 4 now, a is equal to a by 2 if we go for doing that. Now what he did is 3, 2, 1, 0, and then he just printed the remaining numbers after that. A is equal to a, 4, and yeah, that's it. That is what he did to minimize the pairwise XORs. This logic is bit like difficult to strike, but yeah, the thing here is 3. What is 3 is binary representation. 2 power 0, 2 power 1. Yeah, 1 comma 1 is 2's binary representation, 3's binary representation, and 2's binary representation is 1 comma 0. If we take the XOR, we get as 1, and if we take the XOR of these both, 1 0 0 1, it's 2. XOR of 1 and 2 is, wait, I guess it will be 3, not 2. 2 XOR 1, 1 0 1 0, yeah, it will be 3, and this will be 1, and this will be the maximum thing. Just on the maximum set bit and put in the remaining values. Let's see the discussions of this thing. No comments. Okay. Try to remove the higher set bit contribution by playing those numbers which has the same bit set. I will try to remove the higher set bit contribution, placing those numbers together which has the same bit set. To minimize the maximum XOR of adjacent elements in permutation of size n, separate the number of into two groups as on higher set bit k in n minus 1. Those with kth bit unset and those with it set. Okay. Place the unset group in first decreasing order and unset group so that XOR large XOR occurs in two between keeping all others. So the idea, I think it worked over here. What I did is, first thing I did this to find the most significant bit here. Log to n will give me more significant bit. I don't need this function anyhow. And then what I'll do is I'll find power of 2 comma k. That will only be the maximum cost for me. I mean, out of all the minimum pairwise cost, this will be the maximum cost. And then if we go on, I'll just print which don't have this kth bit set, those numbers. I'll simply print them in reverse manner so that they'll just get the minimum XOR. And here I'll print those numbers in increasing order. Here also I'll get minimum XOR. The only maximum XOR is what I'll get is between 0 and x, which is the power 2 power of the set bit. This is how we'll get the answer. The intuition was to know which bit is set or not. It was quite, I mean, it was quite difficult to find the when do we get the maximum cost out of all the minimum pairwise costs. So that is only when, I mean, that is only the highest set digit. I mean, whatever the digit is set in that number, that will only be the minimum cost out of maximum cost out of all the minimum costs. Power of 2 of that, whatever the digit is set. So yeah, that's it for today.